What's up, ladies and gentlemen, boys and girls? Today we are going to be talking about raycasting. Now, raycasting is a very common thing to be doing in games. It's a very common thing that happens in all sorts of games. Mainly, you'll see it used in shooters, but it's a topic that not a whole lot of people actually know what it is. But raycasting is essentially just throwing out a line, a straight line, in any direction really. And these things can be used to identify items for pickup. They can be used for just about anything. But the most common use for raycasts in games most recently has been in guns. In shooters where we have objects, instead of having actual bullets spawned into the level like we have here in our template, a lot of times we'll see a situation where a ray is spawned instead of the bullet. The rays have several advantages. They can be used in different calculations for penetration, so we can have something go through an object. They're easier to control for bounce because there's no physics applied to them, and all sorts of things. However, bullets do have their own advantages as well, such as adhering to the laws of physics that we have. So it's easy to make a bullet curve. You can't actually make a bullet curve if you're doing raycasts. And there's travel time, so things tend to be more realistic. But today we're going to be just focusing on how we can do the raycast as opposed to the benefits and merits of each technique. So to get started, we're going to come into the tutorial character C++ source file. Once again, I'm using the first person template. And what we're going to do is we're going to come into our onFire function, which we've used dozens of times in this tutorial before, in this series before. And we're going to get rid of everything. Boom. So as you saw before, what we were doing is we were spawning our tutorial projectile actor, and now we're just going to be spawning a ray. So with that being said, we really, if we wanted to, we could come into our components and we could actually get rid of, where are you? We could get rid of our projectile class. We don't need that anymore. We can also, if we'd like, go into our included files up here and get rid of our projectile, because we're not needing those. Completely irrelevant for what we're going to be doing. So we've deleted all of the source that's inside of the onFire function. So what we're going to do now is we're going to create our ray. First thing what we're going to do is we're going to need a starting location for this ray, and we're just going to make it start location, and it's going to be equal to the actor's location. So if you're going to be shooting a gun, you want the gun shot to start at the actor's location, so at the player's location, right? You wouldn't want it spawning 10 yards to the right. And we're going to need another F vector, and it's going to be our end location. And that is going to be equal to whatever is in front of our actor, in front of our player, where he's looking at a certain distance. So first what we're going to need is we're going to need to get the start location, because that's where we need the rest of this to come from. And whatever we have here, we want to make sure it's in parentheses, just to make sure that there's no funny stuff going on with order of operations when we're dealing with math. You know, just basic stuff that you learned in 5th grade probably, I don't know. So now that we have this here, we're going to need the direction and the distance that the ray is going to travel. So the direction is going to be whatever we're looking at. So we're going to get first person camera component, and we're going to get its forward vector, because that's where we're looking, right? Makes sense. But the forward vector is only a unit vector, so it's got a length of 1. So it'll only be traveling 1 centimeter in front of the player, probably won't even do anything. So what we can do is we can multiply this by a certain distance. You could store in a variable for the distance, but here I'm just going to use a value of 4,000. And obviously it's just going to take in a float like much else in the language. Or I'm sorry, in the engine. So now we've got our start location and our end location. Now we have some other things that we have to talk about. The first of them being what is known as a hit result. So what we're going to do here is we're going to go f hit result, and we're just going to name it hit. Now what the hit result is basically think about it like exchanging insurance information after a fender bender. So what we're going to be able to do with this hit result, it is a struct, by the way. What you're going to be able to do with this hit result is you'll be able to get the information of whatever you just hit. So if I say hit dot location, I can get the location of whatever I hit. Right here you can look and see we can get the actor, whatever we hit. We can get the component, we can get the name, we can get the impact normal, we can get all sorts of information basically from this hit location. And that's how we're going to actually interact with with different objects through the raycast. So now we're going to go to and create another variable, and it's going to be f collision query params, and we're just going to call this collision params. And what this does is it allows us to customize how the raycast interacts with the environment. And for this, what we're going to do for this tutorial, we're not going to do it for another tutorial, which is going to be coming in a couple weeks. Is what we're going to do is we're going to set a different parameter for this collision params, and we're going to call collision params dot add ignored actor. We're going to add this, meaning a reference to this character. We're going to add this, our main character, to our add ignored actor. So what that means is if for some reason our raycast collides with the player that fired it, then it's going to ignore it. Because we don't really want it to happen in case you have different colliders for other things set up. We want this to ignore all of that. Now we're not going to do that for a different tutorial, like I said earlier, because that's going to do something special. But after that, we are now ready to spawn our ray trace. So get world, and then we're going to do line trace, and you can see we've got tons of different line traces that we can do. We can do multi by channel, multi by object type, multi by profile, but what we're going to be doing is single by channel, because we're only going to be spawning one line trace, and we're going to identify which objects we should hit by what's called our channel. So the first parameter we're going to pass in is the hit result. Oh, we just called it hit. Now we're going to go to our start location. We're going to go to our end location. And then next we have our e-collision channel trace channel. And basically what that's doing is it's going to specify which components of the world we can hit. Now if we go in and say ECC, that stands for e-collision channel, we can look in and see we've got camera, destructible, engine trace channel 1. There's tons of different options that we can do. What we're going to be using today is ECC visibility. We want to be able to hit anything that's visible. Anything that's visible is vulnerable to being hit. Now you can change that obviously. If you only want the hit result to return results that hit other players, you can do ECC, I think it's world dynamic. Yeah, world dynamic is what you'd probably use for actors and other objects in the world. But for this, we're just going to use visibility because we're not doing anything entirely special with this. And then the final thing that we're going to pass in is our collision params. All right, now we have our raycast spawned off. We can save and come in and compile. What I should be able to do is, what we're expecting is I fire the gun and hopefully we'll be able to get some sort of result from it. And I'm actually not getting any results. I can't tell if the gun is being fired at all. The problem with that, obviously, I don't know what's going on. But the reason is because our raycasts are actually invisible. They're not going to show up because that's just the way that they've been set up. So what we're going to do is we're going to come in and we're going to add in a debug line. So what we have to do in order to get our debug line functionality is come in and include another Kismet library. Pretty sure we've used Kismet before. And this one is in Kismet system library. Somewhere in here, Kismet system library.h. Go ahead and include that. And we can come back down and say u Kismet system library. Ooh, can't type today. And now, of course, in our Kismet system library, we've got tons of different functions that we can use. Right here, I'm going to go to draw debug line. First, we're going to pass it in the world because it needs to know what world it's in. Now it's asking for just about the same information that our line trace was asking for. So we're going to give it our start location. We're going to give it our end location. And now it's going to ask for a line color. What you can do is you can do this in a number of ways. You can go F color and specify a color using RGB values. So you can say 25500, and that'll be red. And you can do that and create your own custom color within the RGB space. Or what you can do is you can be lazy like me and F color : red. And it's just going to give a default red value. I believe it's just 25500. All right, now that we've passed that in, we want to pass in the duration. How long is the raycast going to stay? I'm only going to let it stay for 5 seconds because that gives us just enough time to identify where it's going, and that's really all we need, right? And then the thickness. It's set by default to 0. I'm going to bring it up to 3 just to make it easier to see. And with that, I should be able to go ahead and save. And now when I fire the line, or when I fire the raycast, we should be able to see the line that the raycast takes. Alright, now I hit play, and now I can shoot the raycast, and you see it. And after 5 seconds, it disappears. So I can keep firing these off. And this is basically how the guns work in most modern games nowadays. If you think about Call of Duty, if you think about Titanfall, Battlefield, Counter-Strike, this is how a majority of the weapons are made. There are some games like Halo that have projectile weapons, which is basically what we had at the start. But a majority of modern first-person shooters and third-person shooters nowadays actually will they'll use the line trace method. Now, as you can see, our line trace is actually going on through these objects even though we hit them. But that's just our debug line. If we actually stop the debug line before our end location, then we'll be able to see exactly what it's hitting and where it's hitting it. So instead of passing in our end location to this debug line, what we can do is we can pass it in our hit result location. So if we type in hit.location, we can access where the line trace actually ended. Because once it hits something, it'll stop. At least in the way that we set it up here. You can actually set it up so that it can go on for a certain amount of distance later and have bullet penetration or something like that. But for our needs right now, what we're going to do right here is we're just going to have it stop when it hits something. So if I hit play and I shoot this block right there, you can see it is no longer passing through. So that's cool. What I can also do is let's try this out. We can do UE log, and I'm going to go log temp, pass it in via warning, and have the text be hit dot, can I get name, get actor, get name. Yeah, so get actor is going to return a pointer to the actor. And what's this? Formatting string must be tchar array, sorry. Let's say, how about fname? Get fname. Will that work? Can I pass this in? So fname hit actor name is equal to this guy right here, and then pass in hit actor name. Will that work? Let's go to hit UE log and printing log messages. Log and fname. Here we go. I'm just going to copy and paste this because I'm lazy right now. So now what we're going to do is get actor, hit.get actor, get fname, to string. Okay, what I wasn't using is I wasn't using the printf specifier that it actually wanted right here. So that looks like that works. Let's go ahead and compile that. And I'm going to actually open up the log right here just so that I have it ready. Compile failed. What? Why? Why? Oh, I left it as a at the regular old thingy thing. Hit actor, get name. I don't want to dereference the hit result. As you can see, today is the day of the solar eclipse, and that's my address. yeah, I'm getting ready to wrap this tutorial up so I can go ahead and check that out. Compile failed again. What's going on? Did I need to dereference that hit actor? Here, I'm dereferencing it. UE log temp warning. Text my character is. Yeah, okay. Compile complete. All right, let's see. We go ahead and hit play, and then boom. Yep. Warning: my character's F name is editor cube 8. I come in editor cube 17, and basically that's just that's one way of doing. If you've ever seen PUBG, which you probably have, PlayerUnknown's Battlegrounds, you'll see that when somebody gets attacked, it'll say so and so killed so and so. This is an easy way for you to determine or to figure out who hit who. So my character you can replace with the Steam username, and you can say that it hit blah blah blah, whatever it hit. So that's actually it for today. If you have any questions, comments, concerns, make sure you can hit me up via the comment section down below or tweet at me. My Twitter handle is I am at not from Egypt. Go ahead, hit me up on one of those platforms and I will get right back with you. And I'll see you in the next one.